Hello again and welcome to another example of linear programming, which is really systems of equations with something at the end that we have to maximize or minimize. So let's look at this example. It says a farmer has 320 acres, a 320-acre farm on which she plants two crops, corn and soybeans. For each acre of corn planted, her expenses are $50, and for each acre of soybean planted, her expenses are $100. Each acre of corn requires 100 bushels of storage and yields a profit of $60. Each acre of soybean requires 40 bushels of storage and yields $90 of profit. If the total amount of storage space available is 19,200 bushels and the farmer has only $20,000 on hand, how many acres of each crop should she plant in order to maximize her profit? What will her profit be? Okay, so one of the toughest things about this problem is the fact that they've kind of mixed some of the information throughout. It's not necessarily as sequential as the first example that we did together. So let's identify information that is kind of similar here. So if we look at, I see in the second sentence here, I see for corn, expenses are $50. Okay, soybean, okay, expenses are $100. Okay, that was kind of nice. Let's pick out some other information. Storage for corn, 100 bushels of storage here. But notice the 60 isn't related to storage, but here the 40 bushels of storage is for the soybeans. Now, these are both related to 1,920 bushels altogether. And back to the expenses, these two expenses here are really connected to the $20,000 that she has to spend. Okay, she can kind of buy with $20,000, but corn costs this much and soybean costs this much. She has storage space. Corn takes this much, soybean takes that much. She has that much space. So those pieces are kind of connected to each other. We also see there's profit of $60 and profit of $90. Well, that's going to go into what we're maximizing the profit. So we'll come back to that in a little bit. The other piece of information here is the fact that we have 320 acres for her two crops. So let's try to piece some of this information into some inequalities. Well, before we even get there, let's talk about our variables. So we're talking about how many acres of each should she plant. So let's go ahead and say X is the acres of corn and Y is the acres of soybean. Great. So if there's 320 acres together and those are the two plants, well, we clearly know that X plus Y must be less than or equal to 320. She can't plant more than that. She probably should plant all of that, but she could plant less than the 320 acres if that was a good plan for her. So let's now look at the information that we found from the orange statements. Expenses, $50 for the corn, $100 for the soybean, $20,000 on hand. So 50X and 100Y. That's how much it's going to cost her to buy the soybean, to plant the soybeans, basically. So she can't spend more than the $20,000 she has. So that must be less than or equal to that $20,000. All right, great. We also know from the storage standpoint that the corn, it's $100 bushels of storage for the corn, plus 40 bushels for the soybeans. But altogether, that must be less than or equal to the total amount of storage space she has, which is 19,200. Great, very exciting. We also simply know that we can't have negative corn or negative soybeans, so they must both be greater than or equal to 0. So that's our system of inequalities that we are ready to go ahead and plot on our axes here. Okay, so from looking at this, I'll tell you in advance that for the x-axis, I'm going to go ahead and count by 20s, which really means that I'm going to skip lines and count 40s. So 40, 80, 120, 160, 200, 240, 280, 320, 360, 400. Great. Let me just mark down that this is corn down here. All right, we'll go to our other axis. Now, for the other axis, I know I'm going to have to go a little steeper. And how do I know what I have to go by? So we really want to I should have done this first, find the intercepts for each. So this, if we plug in 0 for x, we get 320 for y. If we plug in 0 for y, we get 320 for x. So that tells me I have to at least go up to that much for that equation. But we really want to see for each equation, so we make sure we can fit all of those intercepts in. So here, if I put in 0 for x, I get 200 for y. And if I put in 0 for y, squeeze that in there, I get 400 for x. So that's now pushing our bounds a little further here. For this next equation, which is kind of the storage equation, if I put in 0 for x, I get 480 for y. And if I put in 0 for y, I get 192 for x. All right, so that should help us to know where we needed to go. So as you see, for the x-axis, getting up to 400. So you see the x-axis getting up to 400 was enough. But for the y-axis, we got to get all the way up to 480. So I'm going to count actually by more on the y-axis. I'm going to count actually by 40s, which means I'm going to mark every other line as 80. So 80, 160, 240, 320, 400, 480, 560, and that's far enough for our soybeans. Okay, so let's go ahead and plot these. I'm going to go ahead and put our blue equation on there first. So it was 320 on both, so 320 there and 320 there. And it is going to be a solid line. Yours will look much nicer than mine. It's so bad to try to draw a straight line on this tablet. Again, please grab a ruler. All right, for the next equation, we've got intercepts of 0, 200. So that's 160. So yes, this is 200 right there. And we've got 400, 0 way out here. So let's go ahead and connect those. Again, it is a solid line. That's slightly better. All right, great. Let's next grab our purple equation. It has intercepts of 0, 480, and 192, 0. So 192. We're not going to be able to plot that exactly, but in the middle here we know that's 180. So 190 is halfway in that square, so kind of about there. Dot's so big it takes up everything. All right, so we'll connect a point between those. Let me try that again. Try to get a little bit better. Again, rulers will make that much nicer. Might be unnecessary to kind of really plot them, but our last equations are basically telling us that it's got to be in that first quadrant, so don't have anything below there. Okay, so what is our ultimate shaded region for this? So we've got every equation is really less than, and so you can see quickly if we plugged in 0, 0 for every one of these equations, they'd all be true except for our x and y is greater than a 0. So we're really under all three of these lines. So we're talking about this region. Let me get a bigger thing to shade here, down here. Great. And you might be actually noticing that the blue line had almost no effect on our work here because it's really just kind of trapped below the orange and the purple line. Okay, now here is an added wrinkle to this problem. This point is a messy point. Sorry, right here. That point is going to be hard to identify, but we really need to know what that point is. So how can we find out what that point is? Well, it comes from the intersection of the purple and the orange lines. Our graph is just not accurate. Even if you used a ruler and made some nice lines, it's really just not going to be accurate enough to tell where those points intersected. So if we're just looking for where they intersected, that's really a system of equations. So we're basically taking the orange line of 50x plus 100 y equals 20,000. And the purple line of 100x plus 40y equals 1,920. If we solve this system of equations, we will find that point of intersection for those two lines. Well, great. So it's really not too bad of a system to solve for. I'm going to go ahead and multiply the top equation here by -2, and then I'll write it down beneath here. So negative 100x minus 200y is equal to negative 40,000. Great. If we go ahead and add the second and third equations we see here, we get negative 160y equals negative 20,800. And then if we divide both sides by negative 160, we get y equals 130. Great. We'll go ahead and plug back in to figure out what our c value would have been and what our x value would have been. And we can put in 50x plus 100 times 130 equals 20,000. Okay, great. So that's 50x plus 13,000 equals 20,000. Subtract 13,000 from both sides. We get 50x is equal to 7,000. And we divide by 50 on both sides. And we get that x is equal to 140. So that point of intersection on our graph here is the point 140, 130, which is kind of nice of a number. It's not too messy, but it's just going to be really hard to identify that without solving the system to be extra sure. Okay, so we have our feasibility region, our feasible region. So we have the one intersection point here. Well, the other ones were our x and y intercept of these lines. The x-intercept of the purple equation, which we know is 192, 92, 0, and the y-intercept of the orange equation, which was 0, 200. So those, along with the origin, 0, 0, are the points that could potentially be the maximum profit for corn and soybeans. So what equation can we come up with for the maximum profit? So profit, if you look up above, we get $60 of profit from every x is corn, from every acre of corn, and $90 from every acre of soybeans. So we need to use this equation to find out the maximum profit for each of our corner points. All right, well, if we use the point 0, 0, hopefully it's pretty obvious that the profit is equal to 0. If we use the point 0, 200, well, P is equal to 60 times 0 plus, I'm sorry, I keep going back and forth between x's and y's and s's and c's, and I apologize. That's a 90y there. And 90 times 200. Okay, well, 90 times 200 is going to be 18,000. Okay, so that's a potential profit, but let's keep trying our other ones. So let's try 192, 0. So this time it would be 60 times 192 plus 90 times 0. All right, so for this instance, we're going to get 11,520 plus 0, or just 11,520. So that would be our profit from that one. But what about if we made, we use the point 140, 130. For this one, we would have a profit of 60 times 140 plus 90 times 130. Great. So that is 8,400 plus 11,700 for a total of 20,100. Okay, that is definitely the highest profit. That means the farmer should plant 140 acres of corn, 130 acres of soybeans for $20,100 of profit. A lot of work there, but if you take it a step at a time, you'll get to the answer. Thanks again.